I have the 4 conic sections, and I would start with the circle. So you just write on your paper, circle. You draw a picture of a circle. Label the center. You tell me, what am I going to label it? Of course, HK. I'm going to pick a point somewhere on the circle. It can be anywhere. I'll pick that one, but it can be anywhere. And you draw that radius. Try to draw it a little straighter than mine. And I'm going to label this point XY. XY is always the point I pick out on the conic section. Now I'm going to put these 2 points into the distance formula. Now I'm going to only write the distance formula one time here. Get this right off your card. It's x2 minus x1 squared plus y2 minus y1 squared. And now putting this specific situation in here, d is the radius right here. And now I'm going to go big square root, and it's going to be, I'm going to subtract this direction, that way. X minus h quantity squared plus y minus k quantity squared. Just put these 2 specific points into that distance formula. Alright, now I'm going to square both sides. So when I square this, it becomes r squared. When I square this, the square root and the squared cancel each other out, and I have the general form for a circle. So the only thing I'm going to do is flip the order and put the x minus h quantity squared plus y minus k quantity squared on this side. And I'm going to move the r squared over the other side, and I'm done. There's the general form for a circle. Any questions?
Can I move
Yes,
to that
you can
shape?
move.
Yeah.
So now I'm done with the circle, and I write on my paper parabola. And we'll derive the general form for the parabola going up. Could pick any of them. We just did up before, so we'll do up again. I need to label the parts. First of all, the vertex. The vertex is HK. Good job. The focus would be up here somewhere. Now, which of the 2 coordinates stays the same when I move straight up? There's different mumbles. It's the H. Yeah. H stays the same. K changes by C. So this is K plus C. My directrix would be down here somewhere. But because it's a horizontal line, every horizontal line in the universe is x equals something. In this case, it would be sure what? K minus C. Now I need to pick a point anywhere on the parabola. How about that one? And now I have 2 distances to deal with. This is distance 1, and down to the directrix is distance 2. Now, what do I always call the point I pick? Always.
XY.
XY in every conic section. Now, I also need this point right here, and since it's moving straight down from here, the x stays the same. The y coordinate of this point is k minus c, because every... Oh, why did someone catch my mistake?
It's
Are
Y.
we smart people in here?
It's a Y.
It absolutely is. Why didn't you say something?
Because he's like, no, it's not. It goes sideways. So
It does go sideways, which is why it's y equals k minus c. Okay, pause it for a second, Brayden. Here we go. I have the entire parabola. I have drawn and all the parts labeled, which is the vertex, focus, directrix. I drew my 2 distances in. I've got my 2 points labeled. We got the directrix correct now. And now we go over to the definition of a parabola. The definition of a parabola is distance 1 has to equal distance 2. A parabola is all the points that are the same distance from the focus and the directrix. So if I have 2 distances, I need 2 of these things. 2 big old square roots, because I'm going to use the distance formula twice. So right here, distance 1, I'm going to use these 2 points, and it's x minus h quantity squared. And y minus, okay, this is a little weird, but this is just a number, k plus c. So it's minus k plus c quantity squared. Distance number 2 is right here. So this time it's x minus x squared, which is really going to be 0 here in a second. we were actually doing all the algebra. X minus x is 0. But I'm going to leave it in there right now so remember that I did it. And then it's y minus, and I'm right here, y minus k minus c. Again, k minus c is just a number. And all of that, I'm just going to get in here, is squared. Okay. Once I have that set up, I'm going to let you do this. And that arrow means you do a whole bunch of algebra. And when you do a whole bunch of algebra, your answer comes out to be y minus k equals, I'm okay if you want to put an A here. Whoops. Should have put another equal sign though. What should have went there? What goes after the A? Parenthesis and x minus h quantity squared. Now, if you put an A here, then you need to make a note and say A equals 1 over 4c. Because there's no A up here. So how could you do a whole bunch of algebra and magically get an A? Well, somewhere you made a substitution for a 1 over 4c. Or you could just put the 1 over 4c in here. I really don't care. And there's the general form for the parabola going up. Questions? Ready for the ellipse? All right, so next, on your paper, you write ellipse. And let's draw the picture of a sideways ellipse. Again, could do the up and down just as easy. We've got to pick one of the two, so sideways is good as any. And now label the parts. Well, we're just going to derive the equation from the one at 0, 0. That's good enough. So the center is going to be 0, 0. Which makes this point, you tell me? Uh-oh. Nope. That's a vertex. There we go. A0. Negative A. 0. This point? 0B. A co-vertex. And the other co-vertex is 0, negative B. And now we need two foci. One right there and one right there. Which would be? Yeah, C. So this one's negative C. So just like I did with the circle, just like I did with the parabola, I draw the picture of the ellipse and label the parts. Then, what did I always do next? Well, no, before the distance, someone just said it, you pick a point. And you always, that's a comma, always call that point XY. This time I'm going to draw a line to each focus. And now I have a distance 1 and a distance 2. And the definition of an ellipse is that distance 1 plus distance 2 always equals 2a. In other words, the sum of focal radii is always 2a. So now it's distance 1 plus distance 2 equals 2a. Distance 1 will be right here. It's x minus c. Quantity squared. And it's y minus 0. Quantity squared. Distance 2, that's supposed to be 2 right there. X minus a minus c, so this one's actually x plus c. And again, it's y minus 0. Question so far? So here's where we do a whole bunch of algebra. And if we do our algebra correctly, the answer for a sideways ellipse is going to come out to be x squared over a squared plus y squared over b squared equals 1. Now, just like I said for the parabola, we have a little problem. There's no b in here. There's an a right there, 2a. There's c's, so how in the world did you get a b? They made a substitution. Is a squared minus c squared. Somewhere in there you made a substitution, and that came out to be the general form. Any questions? All right. So then I'll slide this up, but on your test you're going to move down your paper, and now you're going to do the equation for a height. We start by drawing the picture, and I'll draw a side wave. We'll label the parts. The sector's going to be 0, 0. This is, you tell me.
A.
It is A. Good job, because it's a vertice. It's A, 0, negative A, 0. Foci are out here at C0 and negative C0. So I have drawn the hyperbola and labeled its parts. What's next? What's it? Pick a point and label it X, Y. See the pattern? I mean, every time you draw the picture, label the parts, pick a point, call it X, Y, and again I have to draw in the focal radii. So to each focus, here's distance 1, here's distance 2, and now in the hyperbola, distance 1 minus distance 2 equals 2A. It's the difference of focal radii that makes 2A. Now I need square root minus big square root equals 2A. Okay, distance 1's right here. X minus a minus C, which is X plus C. Y minus 0. Distance 2, X minus C. Y minus 0. What's right here? Y minus 0. Squared. Do a whole bunch of algebra. And the answer comes out to be x squared over a squared minus y squared over b squared equals 1. Once again, b squared just magically appeared. So somewhere along the line we made a substitution. B squared this time is c squared minus a squared, which you can get all these you can get off of your card. Actually, this you can get off your card. You have to memorize anything. I don't think you have to memorize much at all on all of these. You have to know the pattern. Draw the picture, label the parts. Pick a point somewhere and call it X, Y. Put the respective distances in the distance formula, and it falls right out. And that's where you find how you derive the general forms of the conic sections. Okay.